Have you ever wondered how space travel affects the human body? As we sit here on Earth gazing up at the stars, it's hard not to be captivated by the mysteries that lie beyond our atmosphere. For centuries, humans have been intrigued by the vast expanse of space, and it's only in the last 60 years that we've been able to physically explore it. The first human-made object to touch the stars was the Soviet Union's Sputnik, launched in 1957. This satellite was not much bigger than a beach ball, yet its journey into space marked a significant milestone in human history. Since then, we've sent people to the moon, rovers to Mars, and probes into the furthest reaches of our solar system. But as we venture further into space, we must also understand the toll it takes on our bodies. Unlike Earth, space is a harsh and unforgiving environment. The absence of gravity, the exposure to cosmic radiation, and the isolation from Earth can have profound effects on the human body. One of the most well-documented effects is the loss of muscle mass and bone density. Astronauts in space can lose up to 2% of their bone mass for each month they spend in space. They also suffer from muscle wasting, as their bodies adapt to the weightless environment. Another intriguing effect is the change in vision. Many astronauts have reported vision changes after spending time in space. This is believed to be caused by the shift in bodily fluids towards the head due to the lack of gravity. These are just a few of the known effects of space travel on the human body. But as we prepare for long-duration missions to Mars and beyond, understanding these effects and finding ways to mitigate them is more important than ever. So, let's delve deeper into the astounding ways space travel impacts us humans. Stay tuned as we explore muscles in space, the bone density dilemma, vision in the vacuum, and the implications for long-duration space travel. Picture this. You're in space, floating in zero gravity. Sounds exciting, but what about your muscles? Muscles are a fascinating part of our body, constantly working, even when we're at rest. They're designed to function in Earth's gravitational pull. But what happens when we take that pull away? When you're in space, your muscles aren't working against gravity anymore. The result? Muscle atrophy. Yes, your muscles start to waste away due to lack of use. In the zero-gravity environment of space, your body doesn't need to use as many muscles to move or to stay upright. Over time, this lack of use can lead to significant muscle loss. This is particularly true for the muscles in your back and legs, which on Earth are used heavily for standing and walking. And it's not just the muscles in your legs and back that are affected. Your heart is a muscle too, and it doesn't have to work as hard in space as it does on Earth. Over time, this could lead to a decrease in cardiovascular fitness. So what does this mean for astronauts? Well, they have to work hard, really hard, to maintain their muscle strength and cardiovascular fitness while in space. They spend around 2 hours each day exercising, using specially designed equipment that simulates the resistance our bodies would usually experience due to gravity. But even with this rigorous exercise routine, astronauts can still lose up to 20% of their muscle mass on space flights lasting 5 to 11 months. This muscle loss could affect their ability to do their job or even to escape in case of an emergency. And what about when they return to Earth? Astronauts often need many weeks or even months of physical therapy to regain the strength and muscle mass lost during their time in space. So while the thought of floating around in space might seem like fun, the effects on our muscles are a serious consideration. It seems space isn't really a gym for our muscles, is it? Bones, our body's support system, face their own challenges in space. What happens to them? Well, let's dive right in. In the absence of gravity, our bones undergo a peculiar transformation. Here on Earth, our bones are constantly remodeling themselves, a process that involves the breakdown and rebuilding of bone tissue. This remodeling helps our bones adapt to physical stress and repair any damage. In space, however, this remodeling process goes awry. The balance between bone breakdown and rebuilding shifts dramatically. The breakdown of bone tissue continues at its usual pace, but the rebuilding slows down. This imbalance leads to a decrease in bone density, a condition eerily similar to osteoporosis on Earth. Now, imagine this. You're an astronaut, and you've just spent 6 months aboard the International Space Station. Your bones have been slowly losing density all this time. When you return to Earth, you're at a higher risk of fractures, and your bones might take a long time to regain their original strength. But that's not all. This bone loss doesn't stop when astronauts return to Earth. Studies have shown that even after a year of being back, astronauts' bones continue to be less dense than before their spaceflight. This lingering effect is a significant concern for long-duration space missions like those to Mars and beyond. And here's the real kicker. Even with exercise, which is known to stimulate bone remodeling, astronauts can't completely prevent this bone loss. The absence of gravity makes it difficult to put enough stress on the bones to stimulate the rebuilding process. Scientists are working tirelessly to solve this bone density dilemma. They're exploring the potential of nutrition, pharmaceuticals, and advanced exercise regimes to help mitigate this bone loss. Yet the challenge remains. Until we find a solution, our dreams of deep space exploration could be held back by our very own skeletal system. Space, it seems, is an uphill battle for our skeletal system. Ever thought about how space could affect your vision? It's not as clear-cut as you might think. We're diving into a fascinating phenomenon known as spaceflight-associated neuro-ocular syndrome, or SANS for short. This is a condition where long-duration spaceflight can lead to significant changes in vision, potentially impairing astronauts' ability to perform tasks. It's as if space itself is putting on a pair of glasses, altering the way we see things. While floating around in the vast emptiness, astronauts have reported a range of vision changes, from blurry distance vision to seeing bright flashes even with their eyes closed. These changes aren't just minor inconveniences. They can be serious enough to impact mission success and astronaut health. So, what's causing this? It's a mystery that scientists are still trying to unravel. Some suspect that it's due to the lack of gravity causing a shift in body fluids towards the head. This could increase pressure in the brain and eyes, leading to changes in the shape of the eye and the optic nerve. But the plot thickens. Other researchers believe that increased levels of carbon dioxide in the spacecraft could be contributing to these vision changes. Then there's the role of cosmic radiation, which can damage the retina. The truth could lie in a combination of these factors, or perhaps something we've yet to discover. This isn't just a problem for today's astronauts. It's a hurdle we'll need to leap over for long-duration space travel. Imagine setting off on a journey to Mars, only to find your vision blurring partway through. Not ideal, right? That's why ongoing research into the causes and potential remedies for SANS is so crucial. Scientists are exploring everything from new training methods to medication, even specialized eyewear to help protect astronauts' vision. In the grand scheme of things, vision changes may seem like just another drop in the cosmic ocean. But when it comes to exploring the final frontier, every detail matters. Space might alter our perspective in more ways than one. With plans for missions to Mars and beyond, what do these effects mean for the future of space travel? As we venture further into the cosmos, the physiological changes experienced by astronauts become increasingly significant. Long-duration missions could be impacted by muscle wasting, bone density loss, and vision impairment. Imagine, a journey to Mars could take up to 9 months. That's a lot of time for these effects to compound. This reality underscores the importance of ongoing research into countermeasures and treatments. Scientists and engineers are working tirelessly, developing exercise regimens, dietary modifications, and even advanced equipment, all aimed at mitigating these effects. Every discovery, every innovation, brings us one step closer to ensuring the health and safety of future space travelers. But it's not just about reaching our destination. It's about making sure we can live and work effectively once we get there. As we reach for the stars, we must also look inward, understanding and overcoming our own biological limitations. So, space travel, an adventure, a challenge, and a fascinating study of the human body under unique conditions. We've journeyed through the cosmos today, uncovering the surprising ways space travel affects us. We've learned about the muscle wasting that astronauts face, a testament to our body's adaptability in unfamiliar environments. We've also delved into the bone density dilemma, an issue that could pose significant challenges for long-duration missions. And let's not forget about vision impairment, a startling revelation of how our eyes respond to the vacuum of space. These are not just physiological changes, but puzzles that scientists are actively trying to solve. For the next giant leap for mankind may very well be a mission to Mars or beyond. Next time you look up at the stars, remember, space is not just about rockets and galaxies, but also about the remarkable resilience of the human body. Did you know about these surprising effects of space travel on the human body? If this piqued your curiosity, show some love with a like. Share your thoughts in the comments and subscribe for more intriguing content. Remember, knowledge shared is knowledge doubled.